Good. All right, so 9.2 is on reflection. And the definition of a reflection here. A reflection across a line M called the line of reflection is a transformation with the following properties. The point A is on line M, then the image of A is itself. So if we have a point on the line of reflection itself, it does not move. It stays in the same spot. If a point B is not on the line, then M is the perpendicular bisector of B and B prime. So the line of reflection will be the perpendicular bisector of the line between the point on the pre-image and the image. Okay? We write reflection as a big R and then state line of reflection. So remember translation. We used the notation big T, and then we did left or right, up or down. For reflection, we use big R, and we simply state what the line of reflection is. And this could be in slope-intercept form. Right? It could be just labeled line L, line L, anything like that. So a reflection creates symmetry in our shapes. A line of symmetry is a line over which a shape is reflected. Right, so it's going to create two equal things, two congruent shapes on either side. So if we look at A, how many lines of symmetry do we have? We have two, right? Let's look at it. So I have line of symmetry. That one will cut it right in half. Gotta move that up a little bit. You got off your off by here. So line of symmetry right there. And then what about right here? Notice if I went through diagonal, right, it wouldn't quite create symmetric shape. So this one has two. What about this one? This dark with the heart.
1.
Yes.
No. 0.
Well, if we ignore this part right here, we could say there's 1, but we're going to say 0 because it's not quite the same on both sides. It would have to be perfect. See if you can do C. Take a second, see if you can do C. No, the diagonals will not work. It's not going to put it perfectly symmetric.
Is there more than ours?
Yeah, what else?
1 and 2. All right, let's look at C. How many do we have for C? 3 only? Let's see.
Oh,
1, 2, 3, 4, 5, right? 5 lines of symmetry. All right. So graph the given reflection. Give the coordinates of the reflection. All right, so first, let's go ahead and look at A. I'm going to graph 2, 2. And then I'm going to draw in my line of reflection. So the x-axis here. And remember that definition of a reflection. The line of reflection is the perpendicular bisector of the segment that connects the 2 points. So this is point H here. So I know H prime is going to be down below. How far below? You can just go ahead and count. 1, 2. Down 2 in the opposite direction, perpendicular. There's going to be H prime. So just like that. For B, let's graph G. We have 5, 4. See that in green. There's point G. That's 5, 4. And then we have y equals 4. Is this going to be a horizontal line or a vertical line?
Horizontal. 'Cause it's cool.
Horizontal, right? Remember this, right? If you're having trouble distinguishing between these two, which is key to this lesson, for all values of x, y equals 4. So if x equals 3, y equals 4. If x equals negative 2, y equals 4. What's going to be that horizontal line? So g is right here. So g prime is not going to move at all. It's going to be in the same spot. So g prime would be 5. And over here, h prime, I forgot to write that in, it's going to be 2, negative. For problem C, right, that's going to be a vertical line. So go ahead and see if you can graph it and find the location of the image of J. Here we go. J is at 1, 0. So there's J. And x equals negative 1. That is this vertical line right here in blue. And I can go ahead and count. 1, 2 over 1, 2. There is J prime. So J prime is at point negative 3. I'm going to see. There are these. Let's try some more of these. All right, so let's do each of these reflections. We're going to do these separate. I'll do this top one, and then I'll have you guys do the bottom. Sue. Let's graph each of these. If we need it a little bigger. All right, so I have the points A, which is negative 3, negative 2, negative 5, negative 1, negative 4, negative 5. All right, so there's my pre-image. And let's first reflect this across the x-axis. So draw our line of reflection in there. You know, tell me the equation of the x-axis. What's the equation of the line that is the x-axis? What's 0? Y equals 0 or x equals 0? Y equals 0. Very good. So horizontal line. So the x-axis is simply y equals 0. Right? You say either. So we're going to take each of these points and then move them one on the other side. So down 1, up 1, down 1, 2, up 1, 2 from our line of reflection, and then 1, 2, 3, 4, 5, 1, 2, 3, 4. There we go. And we'll label these. This is A prime, B prime, and C prime. And we'll label these, make sure we label these A, B. We don't have an idea as to whether or not the reflection is a rigid motion.
Yes.
It is a rigid motion. Very good, right? All the angles are the same and all the side lengths are the same. So it is a rigid motion. Preserves distance and angle measures. All right, so let's do this next one. I'll do it in green for you. Now I'm going to reflect it across y equals negative 1. Is this a horizontal or vertical line? Horizontal. Y equals anything is a horizontal line. So I'll do this in green. So here's our line of reflection right here. And Is B going to move anywhere?
No.
No, so B and we're going to call that B double prime. We're going to be in the same spot. A goes 1. So this is A double prime. And then C, 1, 2, 3, 4. 1, 2, 3, 4. B double prime. Do we get the same shape? Yes. Well, what do we notice here? Though our line of reflection is shifted down 1, how much different is our reflection? It's double that. So it's going to be double the distance of the line of reflection if we do two things equal to each other. All right, try B. Or try that next example. All right, so the second example here, I'm going to make my graph a little bit bigger so I don't go off the edge. Let's go ahead and graph this guy again. And my original one in black, -3, -2. There's A. B, -5, -1. There's B. And C, -4, -5. There's C. And the first one, I'm going to reflect across the y-axis. So let's go ahead and draw this. And to find A prime, I'm going to go over 1, 2, 3. 1, 2, 3 on the opposite side. There's A prime. And then this is 5 on this side. I'm going to go over 1, 2, 3, 4, 5 on this side. There's B prime. And then 1, 2, 3, 4. 1, 2, 3, 4. There is C. All right. The next one, x equals 1, is a vertical line. Right here. And remember, just like we did before, now I'm going over 1, 2, 3, 4. 1, 2, 3, 4. There is going to be my A double prime right there. And notice it's 2 further in this direction. So B is going to be 1, 2 further over here. That'll be B double prime. And then 1, 2 further, there's C double prime. All right. So there are 2 reflections. All right. The last page, we don't necessarily always even need to be in the coordinate. Some properties to look at. Reflections preserve distance. Right? So a reflection across line M of point A equals A prime, and reflection across M of point B is B prime, then AB, right? This distance is going to be congruent to A prime, B prime. So those distances are going to be congruent, right? So if we're doing a triangle, this is creating 2 congruent triangles. And they also preserve angle measures, right? So these angles, angle ABC, is going to be congruent to angle A prime, B prime, C prime, right? So translations and reflections, these are congruence transformations, where instead of going through all of that business where we prove sides are congruent using side, 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 or side, angle, side, if I can show that one figure will map onto another figure with a translation or a reflection, I can show those 2 figures are congruent because I can lay one directly on top of the other. All right, so let's look at these. For each triangle is a reflection of another triangle across the given lines. How can you describe triangle 2? By using a reflection. So if I'm looking at triangle 2 right here, we can describe triangle 2 as triangle 2 is the image of a translation, actually not a translation, a reflection across line K of triangle triangle 2 is the image, the reflection across the line K of triangle 4. See if you can give me this rule, but define triangle 3. Okay? You can define triangle 3 using the same. What is triangle 3 the image of? So triangle 3 would be a reflection across the line M of triangle 1. Reflection across the line M of triangle 1.